Chapter 3.5, which is the transformation of functions. So to transform a function, we're speaking about either moving it up or down or left or right. And we're also speaking about either shrinking that function or stretching it. So let's go ahead and start with what's called vertical shifts. If A is a constant, f of x is a function, of x, f of x plus A if we add a constant to the function, we move up. And f of x minus A, if we subtract the constant from the function, we move down. Examples: f of x is equal to x squared plus 3 is the square function shifted 3 units up. To see this, we can use our graphing calculator. Put in y equals as the original function, which is x squared. And we know that square graph looks like a U shape with the vertex at the origin. And into y2 we can type x squared plus 3 and graph it. And we see that the function is shifted 3 places upwards. Capture that and put it in our notes. If we wanted to write, say, f of x is equal to the square root of x minus 3, this is the square root function shifted 3 units down. So to see this, I'm going to graph our basic square root function, clear everything that I have in here, and graph the square root function by pressing second and x squared. Type in an x and I can see my square root function when I graph it. And then if I subtracted 3 from the function, be careful when you do this with the calculator, because you want to make sure that you're out from underneath the square root sign by pressing the cursor button to the right. sorry, it is -3. And we should see our square root function shifted 3 places downwards. It takes the whole function and shifts it 3 places downwards. F of x equals to 1 over x plus 5 is the reciprocal function up 5 units. So I'm just want to make sure that I show you how to graph these, because there's specific ways of doing it. So if I typed in the 1 over x function, I know that it looks like this graph. Remember that from chapters 3.2 and 3.4. And then if I wanted to shift that function up 5, I would make sure that I put that 1 over x in parentheses and then add 5 to the whole thing. And now we can see the whole function being lifted up 5 places. One final example, if I wanted to move, say, the absolute value function down 4 places, so this is the absolute value function down 4 units, I would first graph my absolute value function because I want to remember what it looks like. So I have my absolute value function graphed. And then if I wanted to shift this function 4 units down, again, I would use my calculator. Type in my absolute sign, put in my variable, and subtract 4 from it, and graph it. And there I could see the absolute value function shifted 4 units down. Okay, so now let's talk about horizontal shifts. We talked about vertical shifts just now. Let's talk about horizontal shifts. And these shifts move opposite of the constant. Now, f of x equal to some function say the square function. I kind of wanted to give this a little bit. F of x, let's give it another name, right? F of x plus a, where if I add directly and a directly to the function, means the function is shifted left. Remember, opposite of the function, so left a units. And fx minus a the function is shifted right a units. So f of x is equal to x plus 3 squared is the square function shifted left 3 units. So again, I want to pull up my calculator here and look at what I'm talking about. So I'm going to go ahead and clear my previous graphs out of there. And if I were to type in open parenthesis x plus 3 squared, I could see that my function has been shifted to the left 3 places. Okay, that function has been shifted to the left 3 places. If I wanted to, say, shift this absolute value function this is the absolute value function right or units. So I'm going to go ahead and graph my absolute value function x minus 4 in the absolute sign because it's attached directly to the x value of the function. And it's shifted right 4 units. So always go opposite of the sign. If I wanted to write this is the square root function. So if you were in class, I would be asking if we were going right or left here. Yeah, you guessed it, we're going left 5 units. So square root x, don't come out from under the square root sign now, plus 5. We're underneath the square root sign still because we're attached to the x. And this represents the graph shifted 5 places to the left-hand side. If I wanted to graph, say, the cube function, let's move it to the right instead, minus 6. This is the cube function, right 3. So, calculator, open parenthesis, x minus, what did we say, right 6 units to the power 3. And here we have our cube function shifted right 6 units. I know you guys saw that mistake, right? This should be right 6 units, not 3 units. So if I'm thinking about how to apply this further, if I had, say, f of x is equal to one over x minus 2 plus 3, this is the reciprocal function. Then the minus 2 here means it's shifted right 2, and the plus 3 means up 3. So to graph that, you want to graph, and be careful with this graph. You have a couple of choices here. You can use alpha and y equals and press number 1 to get the fraction bar, 1 over x minus 2 plus 3. Okay, so this would be one way to do. This is the reciprocal function shifted 1 unit, 2 units to the right and up 3 places. I'm going to show you another way to do that as well. If you're doing it any other way, you'd have to put that one part of the function 1 divided by x minus 2 and then add 3 to the whole thing and graphing it. Okay, that would be one way, another way to do it. Or again, use alpha, y equals, and select number 1. Some calculators do not have this feature. That's why I showed you the second way as well. Okay. All right, now we can move right along. We can talk about compression and stretches. This sounds like a workout program gone bad, right? Compression and stretches. So if the constant in front of the function is between 0 and 1, in other words, it's a fraction between 0 and 1, the graph is vertically compressed. Okay, so if I have f of x is equal to half x squared, vertically compressed means it has the effect of somebody like literally stepping on the graph and flattening it. All right, to see this, we can perhaps graph the original function and then look at the effects of adding that fraction to it. So if I say x squared, I know my graph looks like this. And if I were to tack a half in front of it, 0.5, you can see the graph has been flattened. And if I were to go even further and put in, say, 0.05, smaller fraction, the graph becomes even flatter. Okay? So, it kind of shows you the effect it has when you write a fraction in front of the function. Now, if a is greater than 1, such as say f of x is equal to 5 absolute value x, it stretches the function, okay, stretches the function by 5 units, or by a factor of 5. In other words, the function becomes narrower. Okay, so let's look at examples of this. If I were to graph my original function as an absolute value function, I know it looks like this. And then if I were to go next and put a 5 in front of it, I want you to see what happens to it. It has the effect of someone pulling the graph up, stretching the graph. Okay? Has the effect of someone stretching the graph upwards. So understand that a number greater than 1 is going to have that effect, the effect of stretching the graph upwards. The next thing we want to speak is about is reflections on or about the X and Y axis. If the negative sign is outside the function reflects about the x-axis. So one perfect way to see this is if we graph, say, this square root function. It's kind of difficult to see reflections on the y-axis with the square graph. So if we graph the square root function, we know it looks like this. And if I were to put a negative sign on the outside of the function, in other words, make it negative square root x, I can see the whole graph is now turned over on the x-axis. Okay, so I'm going to take out the original graph here. And I can see the graph is flipped over the x-axis, negative square root of x. So this is the graph of f of x equal to negative square root of x. And if the negative sign is inside, then the function is reflected on the y-axis. So for example, f of x is equal to square root of negative x, we would expect to see a reflection on the y-axis, yes? All right, let's go ahead and see if that is true, okay? So original function, square root of x, looks like this. And if I were to change my function by putting a negative sign in front of the x, look what happens to the graph. It's reflected on the x-axis, okay? And it has become the negative of the square root of x. So f of x, one more example here, equals to, say, minus square root of x, absolute value function reflected on the y-axis. And as you can imagine, if we were reflecting the absolute value function on the y-axis, you wouldn't see anything with the calculator because you're simply reflecting the graph around itself. Let's see what happens. Second catalog, absolute. And if we were to type negative x in here, the graph would still be the same because it's a reflection on the y-axis. Okay? The graph would still be exactly the same. So some of the square root graph can show you a good reflection of what happens when you reflect it, but not the absolute value graph. All right, so let's spend just a little bit of time describing functions. Describing transformations. If I have f of x is equal to 1 over 5 square root of negative x plus 2 minus 3, and I wanted to describe this in words. Okay, I'm going to describe this in words. This is the square root function. Okay, and you always describe from left to right. Okay, square root function vertically compressed by a factor of 1 over 5. In other words, it makes it wider. Then we see a sign on the negative x, on the x, so it's reflected on the y-axis. Okay, negative sign in front of x, shifted 2 units left. Okay, opposite sign of plus 2. Opposite of 2 is negative 2. And then shifted 3 units down. Okay, So that's a verbal description. Let me give you one more example, and then I'm going to do perhaps one or two problems from the homework. Everything from the homework is kind of covered here, so if you read carefully in the notes, you'll be able to do your homework without a problem. This is the absolute value function. It's a negative sign in front, so reflected on the x-axis, then it's vertically stretched, okay, by a factor of 4, so it's narrower than -1 shifted 1 unit. So minus means it's going to the right, 1 unit right, okay? Opposite of -1 is 1. And then up 2 units. These are called verbal descriptions of graphs, okay? Now, one other thing I wanted to do with you is to tell you how to describe functions going from left to right. So, example, this actually matches number 7 on your homework. Find the function that is finally graphed when the following transformations are applied. So the original function is given as f of x is equal to the square root of x. Number 1, shifted up 4 units. Number 2, reflected about the x-axis. And number 3, reflected about the y-axis. So let's start doing this transformation. We started with f of x is equal to the square root of x. Then we moved it up 4, add 4 to the function. We reflected it on about the x-axis, meaning we put a negative sign in front of the function. So we've got square root of x plus 4 is the function. And we're taking the negative of that function. So this is negative, and then we're taking, if we reflect it on the y-axis, the negative x is there plus 4. So at this point, you probably want to distribute the negative sign to get negative square root of negative x minus 4. Okay, be careful, because that plus 4 becomes a minus 4 now. Once it's reflected, it becomes down instead. One final example. Apply the transformations to f of x equal to x squared. 1. Reflect x-axis. 2. Shift up 7 units. And 3. Shift left 8 units. So we start off with f of x is equal to x squared. If we're reflecting on the x-axis, remember that we're taking the negative of the whole function, which is negative x squared. Up 7, so this is negative x squared plus 7. And left 8 units minus x plus 8 squared plus 7. So the function that is finally graphed is minus x plus 8 squared plus 7.